So, hello friends, hello students. So, today we are going to start the a special type, some special types of matrices, in which there are this some special types of the matrices. Here we are going to discuss. In this one, the first one it is comes, that is the orthogonal matrices. So what is the orthogonal matrices? Dear students, we are planning to start the classes for the IIT JEE mains and advanced level every day at this time at 10 o'clock. ओके, सो ज़्यादा से ज़्यादा मेरे चैनल्स को सब्सक्राइब करें, ज़्यादा से ज़्यादा शेयर करें, ताकि जो भी कैंडिडेट और जो भी स्टूडेंट्स जो IIT जेईई की प्रिपरेशंस कर रहे हैं उनको मेरी वीडियो से कुछ हेल्प मिल जाए. ओके. So now we are just continuing the we are taking it into the full screen. So the orthogonal matrices. What is the orthogonal matrices? If A is a square matrix, a square matrices means of order n by n. A square matrices means in which the rows and the columns are the equal. Okay, so it can be the 2 by 2 order, or it can be a 3 by 3 order, or 4 by 4 order also. Okay, so if A is a square matrices of order n by n, and if it is A dot AT will be equal to I. A dot AT. AT represents its transpose. Transpose means rows will be changes to the column, column will be changes to the rows. So if the multiplications of the A and its transpose of the A is equal to the I means the identity matrix. Okay, then A is called orthogonal matrix. Orthogonal matrix. Okay, so this is the conditions for the orthogonal matrices. A dot AT is equal to I. Okay, and we have also seen in the inverse of the matrices, the product of the A and A inverse will be also equal to I. Product of the any matrix, that is the A, and its inverse of a matrix A, its product will be equal to I. I is the identity matrix. So from here we can say that the AT, the transpose of A, will be equal to A inverse. Getting? So the orthogonal matrices, there will be the conditions if the product of the matrix A and its transpose will be equal to identity matrix, it is called orthogonal matrix. Okay. Now the second one, it is called the idempotent matrix. Same way, if A is a square matrix and if A square is equal to A, means if you are taking the product of the A and A two times, and if it comes equal to A, then it is called the idempotent matrix. Okay, so here we will see one example. If the orthogonal matrices, if the product of A and its transpose is I, so we can take the example of the matrix of the 1 1 1 0 0 0 0 and 0 0. So its transpose will be also the A only, and multiplying with A dot AT, it will give the identity matrix. Okay, here the A is a square matrix and A square is equal to A, then A is called the idempotent matrix. For example, if I take A is equal to 1 by 2, 1 by 2, 1 by 2 and 1 by 2. Okay, so now if I take the A square means A dot A. A dot A means half, and here half, here half. It will be multiplied to another matrix, that is the A. 1 by 2, 1 by 2, 1 by 2. Now it is the multiplications of the two matrices. So here the rows will be multiplied to the first row will be multiplied to the first column. Okay, so we know that the multiplications of the two matrices, it is equal to the half into half, 1 by 4 plus half into half, it will be also 1 by 4. Same way the first row will be multiplied to the second column here. So again 1 by 4 plus 1 by 4, and now the second rows will be multiplied to the first column. So 1 by 4 plus 1 by 4, and the second row will be multiplied to the second column. It will be 1 by 4 plus 1 by 4. So if you are adding these 1 by 4 plus 1 by 4, it will be 1 by 2. So here you can see the square of the matrix A is equal to the A. So it is A is called as the idempotent matrix. Now the third one, that is the involutory matrix. INVOLUTARY. What is the involutory matrix? Same as it is the if A is equal to A is a square matrix, and the conditions for the involutory matrix, it is A square is equal to I. Then we can say that it is the involutory matrix. So for example, if I take the A value 1 1 1 0 0 0 0 0 0. So when you are taking the A square, so it will give the identity matrix. Okay. Now the fourth number, it is the nilpotent matrix. Nilpotent matrix, it is the when A is a square matrix and the A square, A to the power n is equal to 0, where 0 is not 0. Here 0 is the 0 matrix. 0 matrix. It will be the order of n by n. N by n. It can be the zero matrix will be the 0 by 0, 0 by 0, or its determinant will be 0. Okay, so in by 3 in the all the rows and column will be 0. So at which value of the n it will give the a to the power n will be equal to 0 matrix, it is called the nipotent matrix. If I take one example, 0 0 0 2. So now take the first a square. If I taking the a square here, a square 0 0 0 2 0 0 0 2. So multiplying the first rows into the first column. So it will be 0 into 0 0 0 into 0 0. So it will be 0. Now the first row and second column 0 into 0 0. Second row first column it will be also 0, and first row second row and second column it will be 0 into 0 and 2 into 2 4. Okay, now AQ will be equal to 0 0 0 2 and into a square. A square we got the value of 0 0 0 4. So from here it will be 0 0 0 8. Okay, now the next one, it is the Hermiton matrix. What is the Hermiton matrix? It is the, if A is a square matrix and A theta will be equal to, A theta will be equal to A. A theta will be equal to A. Okay, that is A theta. Theta will represents its transpose. A theta, it is the transpose conjugate. Transpose conjugate. Okay, so A to the power theta, it can be written as Aij. Aij is equal to A bar Ji. What is the mean of transpose conjugate? If the terms will be given x plus iy, so its conjugate will be x minus iy. Getting? And if you take the transpose of this one, if A theta will be equal to A, it is called Hermiton matrix. So in the Hermiton matrix, if I take the A value, and here it is 2 3, and here if I take 1 plus I and 1 minus I, so what will be its A theta? A theta will be the its conjugate, transpose of the conjugate, means conjugate, it will be the changing the sign of the positive to negative and negative to positive. It will be possible only in the complex number. Okay, so the diagonal element will be the same, 2 and 3, and it will be 1 minus I. 1 minus I will become here, and this one will be 1 plus I. So you can see it will be equal to the A. So that it is called Hermiton matrix. Now the next one, it is the skew Hermiton matrix. What is the skew Hermiton matrix? That is the sign with the minus sign, minus a theta, a to the power theta is equal to minus a. So in that case, the terms of the aij will be equal to minus a bar ji. So in that case, if I take the example of a is equal to 0, 0 and minus 2 plus I, and here 2 plus I. So if I take the value of the a, if I taking the a theta will become equal to the its transpose of its conjugate, the conjugate of this one value remaining the 200, and transpose of this one will be come this side minus 2 minus I, and transpose of this one will become this side, so it will be 2 minus I. So you can see there is a difference of the minus sign. If I take the minus sign common, it will become minus a. So this is the skew-Hamilton matrix of the example. Okay, so based on this one, we will see one questions. So there is a question is given. So that the matrix A is equal to, it is given 2 minus 2 minus 4 minus 1 3 4 minus 1 3 4 and 1 minus 2 minus 3. These are the matrix is given, and we have to show it is the idempotent matrix. Idempotent matrix, what is it represents? Idempotent matrix, we have seen it is the idempotent matrix, it is the conditions for the a square is equal to a. So what we will do here, we are taking the a square here. So a square will be equal to a into in a. So we will write the matrix 2 minus 2 minus 4 minus 1 3 4 1 minus 2 and minus 3, a into a. This is 2 minus 2 minus 4 minus 1 3 4 1 minus 2 minus 3. So now we are going to multiply these. So the first row will be multiplied to the first column. So 2 into 2 4 plus minus 2 into minus 1 plus 2, 4 plus 2 and minus 4 into minus 4 into 1 minus 4. So it will be minus 4. So the total answer is 4. 2 plus 2 4, 4 plus 2 6, 6 minus 4 2. Now the first row, second column, 2 into 2 minus 4 and minus 6, 2 into 3 minus 6, 4 minus 4 minus 6 minus 10 and plus 8, minus 10 and plus 8, it will become minus 2. Now 2 into minus 4 minus 8 minus 8 minus 8 minus 16 plus 12 plus 4 minus 4. So after multiplication, this one we will get minus 1 3 4. Then so we can see here it is a square will be equal to a. So it is called the idempotent matrix. Idempotent matrix. Okay, there is one example also. We will see the example. So that the matrix A is equal to 1 1 3 5 2 6 minus 2 minus 1 and minus 3. is nipotent matrix and find its index. So if we have seen in the nipotent matrix, it is the a square, a to the power n is equal to 0, a to the power n is equal to 0. So for which value of n, its value will be the 0 matrix. So first of all, we will find its a square. So we are going to find the a square. So a square will be the a into a, 113, 5, 2, 6, minus 2, minus 1, minus 3. And this side 113, 5, 2, 6, minus 2, minus 1, minus 3. So this is the multiplications of two determinant. First row will be multiplied to the first column. 1 plus 5, 6, 6 minus 6, 0. It will be 0. Okay. It is 0. Then 1 into 1, 1 into 1, 1, 1 into 2, 2, 1 plus 2, 3, 3, 3 minus 3, 0, again 0. Then 1 into 3, 3, 3 into 6, 9, 9 into 9, 0. Then again 5, 5 into 1, 5, 2 into 5, 10, 5 plus 10, 15, 15 minus 12. It is 15 minus 12, 3. So similarly, if you are multiplying this, it will get 339 and minus 1, minus 3. Its determinant value is 0, but it is not like 0 matrix. So again, if you are finding the AQ, so it will be the A square into A. A square, we got it already, 0, 0, 0, 3, 3, 9. And minus 1, minus 3. It will be multiplied by the A. A is given 113. 113, 526. Then minus 2, minus 1, minus 3. So now we will multiply these two. So 0, it will multiply with 0, so it will be all 0. Now the second row, first column, 3 plus 15, 18, 18 minus 18, 0. Now 3 into 1, 3, 3 into 2, 6, 3, 3 plus 6, 9, 9, 0. So after multiplications, you will get everything, you will get here 0. So if everything will be the 0, in that case, it will be called as the nipotent matrix. This is 0 matrix. So in the 0 matrix, we can see that here that a to the power 3 is equal to 0. So n is equal to 3 here. Okay. So now we will see another question. It is a very good question. Next question it is, if k minus 1, 2, 2, 2 minus 1, 2, 2, 2 minus 1. A matrix is given A. This is the matrix, it is given A. If A is equal to given, okay, is an orthogonal matrix. Then find the value of K. So in the orthogonal matrix, we know that the A dot AT is equal to I. So we will multiply the A dot AT. A is already given, minus 1, 2, 2 minus 1, 2, and 2, 2 minus 1. Now we were taking its transpose. So transpose, while taking its transpose, the rows will be converted into column. -1, 2, 2, 2, -1, 2, and 2, 2, -1. So this is its transpose. So we are multiplying this one. So k into k, it will k square, and multiplying the two matrices, it will be -1 into -1. 1, 1 plus 4, 5, 5 plus 4, it is 9. Okay. Now multiplying with this one, -2, -2, -4, -4 and +4, it will be 0. Similarly, it comes 0. Same here, it is also come 0, 0, 9. So we know that the A dot AT is equal to identity matrix. The identity matrix, it is like 1, 1, 1, and the remaining elements of the matrix are 0. Okay, so we can equate this one, equate with this one. So we can take the 9 common from here. So it will become 1, 1, 1, and the remaining elements are 0 here. So this is I, and this is also I will be equal to k square, 9k square I will get cancelled. So 9k square will be equal to 1. So from here we can find that k will be equal to plus minus 1 by 3. There is a one good, very good question is given. We will see, so that the homogeneous system of equations is given x minus 2y plus z is equal to 0, and x plus y minus z is equal to 0, and 3x plus 6y minus 5z is equal to 0, has a non-trivial solutions, We have to show that and find its solutions. So here we will see the solutions. It is a homogeneous system of the equations it is given. So any homogeneous system of the equations, we can solve it by the determinant methods also, and by using the matrix methods also. Using the matrix method, we will write its coefficient into we will make the matrix term. So we will write its coefficient. There are the three equations, three variable, and every variable has the coefficient like -1 and 1. This is 1, 1, -1. This is 3, 6, and -5. A, it is given, and the x we are writing in the matrix form, that is the x value, it is in the matrix form, it is x, y, z, because they are the three variable. And b, we are writing the constant value, which are independent of the any variable. Okay, so here it can be written as the ax, the system of the equations, it can be written as ax is equal to b. So multiplying both side by the a inverse, it will give the value of a inverse b. So a inverse a dot, it will be the I into x. So it can be written as a inverse b. So from here we can write x will be equal to a inverse. We know that the formula for the a inverse, it is the 1 by a determinant of a into adjoint of a dot b. And we know that the adjoint of a, it is equal to the transpose of the cofactors. It is the equal to the -1 to the power I plus j into mij. Mij can be obtained by the eliminating the corresponding rows and corresponding column. So first of all, we have to find its determinant value. So what is the determinant of the a? The determinant of the a will be equal to 1 into -5 plus 6. Then expanding along the first row, plus 2 into minus 5 plus 3 and plus 1 into 6 minus 3. So from here we can find its value will be 1 and its value will be minus 2 into 2. It will be minus 4 and plus 3. Its value will be 0. So if the determinant value will be 0, in that case it has the if determinant of A is equal to 0, in that case it has the non-trivial solutions, because x and y has the no specific value, no non-trivial solutions. So for the non-trivial solutions, it is the two cases. It can be the infinite number of solutions, or it has the no solutions. So in the questions it is asking that it has the non-trivial solutions, so we have already proved this one, and it find its solutions means it has the infinite number of the solutions. So for the infinite number of the solutions means it will come in the form of any variable, infinite number of solutions. So x and y and z value will become in the any of the independent variable, like in the terms of the k. So here we will assume the let z is equal to k, because it will be easy to calculate. If I take the z is equal to k and we have assumed this is the one equation, this is the second equations, z is equal to k, so x minus 2y will become equal to x minus 2y is equal to minus k, and of second equations it will become the x plus y is equal to k, x plus y is equal to k, x plus y is equal to k. So from here we are getting the matrix of the 2 by 2, because the z we have already assumed that is the k. Now we have to find the x and y value in the terms of the k. So we will write again in the terms of the matrix. So its coefficient will be 1 minus 2, 1, 1. And the x value, because we are finding the x and y here, z we have already calculated, and here the c value we are taking the last one value, that is the minus k and k. So this is the 2 by 2 determinant, and the system of the equations can be written as bx is equal to c. So x can be written as the b inverse c, and b inverse we can find as the using the formula 1 by determinant of b into adjoint of b dot c. So determinant of b we can find it is the 1 minus 1 minus 1 plus 2. 1 plus 2 it is 3. And adjoint of b can be calculated by the by using the by interchanging these two and changing only the sign. So adjoint of the 2 by 2 order, it will be the interchanging of these two and only the changing of these sign, means it will become this one, and the c value is given minus k and k. So we will multiply this one. X will be equal to 1 by 3. It will be minus k and plus 2k. It will be k. Minus k plus 2k. It will be plus k and 2k. It will be 2k. So multiplying with this one, it will be k by 3 and 2k by 3. 2k by 3. So this is the value for the x. X is given by the x and y. So from here we can write x value. X value it is equal to k by 3. Y value will be equal to 2k by 3. And z value we have already assumed it is equal to k from here. So if you are putting any value of the k is equal to 1. X, y and z are the different value. Okay, k is equal to 2. The x, y, z have the different values. So if you are putting any value of the k, it will give the so much of the values. Okay, so it has the x, y, z value has been came in the terms of the k. So it has the infinite number of solutions. We will see next question. Let A be a square matrix which satisfies the equation equations a square is equal to a square is equal to a means it is the idempotent matrix. Then find I plus a whole to the power 4. So see, we know that the a plus b whole to the power 4, it can be calculated by using the binomial theorem. Its value is a to the power 4 into 4 into a cube b plus 6a square b square plus 4ab square plus b to the power 4. This is the expansions of the a plus b whole to the power 4. So what is the value for I plus a whole to the power 4? It will be also in the form of this one. So I to the power 4 plus 4 into I cube a plus 6 into I square into a square plus 4 into I into a cube. This is the cube. And it will be the a4. So here it is given a square is equal to a square is equal to a. Identity of the n integrals, it will be the I only. So its value will be I. And 4iq, it will be the 4i into a. And 6i square, it will be the also I. And a square its value is given a. So we will write a and a cube. If a square will be a, so it can be written as 4i a square into a, and a4 can be written as a square into a square. We will put the a square value, it is equal to a. So from this one, I plus 4i into a, it will be the 4a, and this one will be the I into a, it will be the 6a, and a square 4 into I a square will be equal to a, and a dot a, again a square, it will be the a. So it will be the 4a and a square into a square, a into a, again a square, it will be the a. So what are the value of all? It will be the value of I plus 10, 15, a. Okay, so we have seen today the different kinds of the matrices, in which we have seen the orthogonal matrix, okay, idempotent matrix, involutory matrix, nilpotent matrix, Hermiton matrix, skew Hermiton matrix, and we have seen the questions based on the idempotent matrix, nipotent matrix, orthogonal matrix, and system of the linear equations we have also seen. Okay, so next class we will see the Cayley-Hamilton theorem for the solving the any system of the equations. Okay, so we present on the everyday on my channel, and ज़्यादा से ज़्यादा सब्सक्राइब माय चैनल, सो दैट जो भी बच्चे जो अच्छी क्वालिटी के एजुकेशन चाहते हैं वो हमारे हमारे चैनल से जुड़ सकते हैं, ज़्यादा से ज़्यादा सब्सक्राइब करें। तो मिलते हैं हम अपनी नेक्स्ट वीडियो में कल इसी टाइम पे 10 o'clock एवरी डे माई वीडियो विल बी स्टार्ट्स। सो प्लीज बी एक्टिव एंड ज्वाइन माई सेशन टुमारो। सो तब तक के लिए सभी को शुभ रात्रि, गुड नाइट। ओके, सो बाय इंडस्ट्री।